Welcome along to our video tutorial series where we're learning how to build Minecraft worlds using Python code. In today's lesson we're going to be looking at building an avenue of trees, which is just putting together some of the work we have done in previous videos. So we've got a path that runs down the middle here, and either side of that path we have some trees. Okay, so everything we have done before. It is a little bit complex in places though, so let's get started and I'll try and explain it the best I can as we go. So I want you to pop over to your Python editor. I'm using Mu, and like always I want you to add in those first two lines of code that we always put in when coding with Minecraft. So the first line simply imports all the functions from the Minecraft module to allow us to build in our Minecraft world with code, and the second line just gets the two apps, Mu and Minecraft, talking to each other. I also want you to add in the code that clears the world off so that you have an empty world or empty canvas to work with each time you run your code. So if I give that a quick run now, make sure you save this as number 10, Avenue of Trees. It should clear your world off, so you've got basically an empty canvas there. There's nothing in your world. If you want me to quickly explain that code, what we're doing is basically from ground level up, we're setting blocks of air, which is just invisible blocks, which wipes out everything above ground level. And the second line there is just adding some layers of grass at our feet. So we've got some grass to build on top of. Alright, whoops, I just bumped a button then to get rid of that, but there we go, it's back. We are ready to get started now on creating this avenue of trees. So the first thing we're going to do is we're going to make a list of the blocks that we're going to be using in our tutorial today. So I'm going to put in a comment here that says building blocks. And there's three building blocks that we're going to be using. The first one is going to be cobblestone. So I'm going to set a variable up called cobblestone, and I'm going to put its block ID stored inside of that. So the block ID for cobblestone, oops, is that going to load back up? Give me a sec. I think the number for cobblestone is the number 4. So just have a look on this block ID list when it pops back up. There it is, cobblestone is number 4. The other blocks we're going to be using today are the ones to make the trees out of. So we've got wood down here at number 17. And also got some leaves at number 18. So we'll put those three blocks in now. So cobblestone was number 4. For the trunk of the tree, I'm going to make a variable called trunk, and I'm going to set that to 17. And for the leaves, I'm going to set that to 18. So they're the three building blocks that we're going to be using today. And you'll notice as I go through tutorials from here on in, I'm going to start labeling my building blocks earlier on in the code. Alright, so now that we've got our building blocks sorted, we can set up the coordinates where we would like to start building today. So I'm going to put in a comment that says set the coordinates. And I'm going to create three more variables here, one called X, one called Y, and one called Z. And obviously these variables are going to be where we store the values of our starting coordinates. And I'm going to start right in the center of the page again at 0, 0, 0. So remember the X-axis is running left to right on our page, Y-axis goes up and down, and Z-axis is moving forward and backwards. And we're going to start at 0 for all of them, which is the center of the page, as I just said. Now that we're in position, we've got the building blocks ready to go, we can build the first thing, which is going to be the cobblestone path. So I'll put in a comment that says that. I don't know why the word like just came up. The cobblestone path, and this is no different to doing a path like we did earlier on in the term. So it's going to be mc.setBlocks. Remember, we're using the setBlocks function to build multiple blocks into our world to build this path. And what we need to put in here is the starting coordinates, so X and Y. And I'm going to put Z minus 2. So we're starting at basically 0, 0, and minus 2 on the Z-axis there. Then for the finishing positions, I'm going to put X plus 56. So on the X-axis, we start at 0 and finish our path at position 56. So that means our path is 56 blocks long. And there's a reason I chose the number 56. That's just so it fits all the trees perfectly down each side. You'll see what I mean when we draw it a bit later on. The Y-axis is going to remain at 0. We're not building up in the air or anything for this path, so it just stays at ground level. And for Z, we're just going to put Z plus 2. So what that means is the Z-axis started at -2, finished at +2, which means our path is 4 blocks wide. The final thing we need to add into this set blocks function is which building block we're going to be using, and obviously we're going to be using cobblestone for this. So write in cobblestone and close your round brackets off. And if you save that up, remember it's saved as number 10, Avenue of Trees. Give it a run, and hopefully you might have to move around a little bit. I can just see it here. There it is. There's our cobblestone path, which is 56 blocks in length. I'm not going to walk it all now. You know what it looks like. There's our cobblestone path, done and dusted. That's the easy part done. The next part, though, gets a little bit more tricky, I suppose. We're drawing the trees that are going to go down either side of our path. Now, each side of our path, I believe, has 10 trees. So instead of writing the code out 20 times for the 20 different trees that are going to be in our world, we want to save time and save code by writing it once. And that's where functions come into play. We briefly touched on functions in a previous video, but I'll just go over it again. What functions are, they are little snippets of code or little blocks of code that can be reused time and time again. So since we're going to be building 20 trees that are exactly the same, there's no point writing out that code 20 times. Let's just write it once, and then we'll just tell the computer to repeat that code about 20 times. Okay, so let's get started. We're going to create a function first of all, and to start with you need to give it a name. So we call this defining a function. And to define a function, we write def and we give it a name. So I'm going to call this function tree, because obviously we're building a single tree. And then in brackets next to it, I'm going to put x, y, and z. It's just taking the coordinates from up here that we set earlier and bringing them inside of this function so we can use them inside of it. At the end of this line, you need to put a colon and then press enter. And you will notice that when you press enter, your mouse cursor becomes indented. And that's important in Python, remember, because that tells Python that all the code that is indented now is the code to draw this single tree. All right, so let's start doing this tree. We'll do it by starting with the trunk. So I'll put a comment in that says trunk and then do the usual code, mc.setBlocks. Remember, we're doing multiple blocks here, building up into the air to build this trunk. In brackets, we just put in the x, the y, and the z coordinates to start with. They're our starting position. And then we're going to put our finishing position. So it'll stay as is on the x-axis, but the y-axis is going to go 5 blocks into the air. And the z-axis will stay as it is. The final thing you're going to put into this function is the word trunk, so the computer knows which block of wood we are building with to build the trunk on our tree. So that's the trunk done. Down a little bit lower, we need to do the leaves. So similar kind of layout here. It's mc.setBlocks again, because we are building multiple blocks of leaves into our world. Now it's a little bit confusing, all the numbers I'm going to use here, but just copy it down. The starting x position is going to be x minus 2. Y position is going to be just above the trunk at y plus 6. And then the z-axis will be z minus 2. To finish off with, for these coordinates, it's going to be x plus 2. Y is going to stay the same at y plus 6. And the z-axis will finish at z plus 2. And we just need to tell the computer we're using leaves to build the green parts of our tree. So you can see the x-axis for the leaves starts at minus 2 and finishes at plus 2. So that means we're going 4 blocks across on the x-axis. For the z-axis, it's the same deal. It's 4 blocks across there as well. So we're going to have a square shape that runs along the x and the z-axis there. And it's going to be 1 block high. As you can see there, the y-axis stays as it is. So that does the first layer of leaves in our tree. I just want to do one second layer, which is going to be the top layer of leaves in our tree. So it's going to be mc.setBlocks. And we'll make it a little bit smaller, this one. It's going to be x minus 1. We're going to make it 1 block higher than the previous one, so it'll be y plus 7. And then z minus 1 again. Finish off with, it'll be x plus 1. Y plus 7 again, and Z plus 1. Then we tell the computer we're using leaves to build that and close our brackets off. If you wanted to, I'll just zoom out here, you could put in a comment after each of these. It just says base layer and top layer. Oops. That just tells you, in plain simple English I suppose, that this is the base layer of our leaves and this is the top layer of our leaves. There's 2 layers of leaves in our tree. Okay, so that's just something to keep in mind. I'll zoom back in a bit here so you can see my code a bit better. That's it. So we've now defined a function, which is a reusable snippet of code. And inside of that function, we've got these lines of code here that basically tell us how to build a tree. Okay, if we were to run that now, we wouldn't see any trees appear. All we would see is the cobblestone path. Okay, if I look around, you can't see any trees. And the reason we can't see any trees is because you need to call this function up. You've actually got to tell the computer to run the tree function to build a tree. Okay, so just to give you a quick example, this isn't the right code that we'll be using in our program, but just to show you quickly, if I jump out of this function, so that means I've moved my cursor back to the left-hand side of the page and just write tree bracket here. I don't know if this is going to work. I think I need to actually add in X, Y, and Z. Yeah, that's what we need. It needs the coordinates. So if I put tree and then add in the 3 coordinates where I'd like to position it and give it a run, it should appear just behind me here. I'll turn it around. There it is. Right at 0, 0, 0, those starting coordinates. The computer knew as soon as it saw the word tree, it was to go back up to this function and run everything inside of it. Okay, so that's how functions work, but we're going to just change that a little bit for what we need to do in this tutorial today. So we've got our tree function done. What I want to do is actually run 10 trees down one side of the path to begin with. Not in the center of the path, but off onto the grass there. So this is how we do it. I'll put in a comment first of all. It says, grow 10 trees down one side of the path. Now I need to make a loop here. So for I in range 10. That tells the computer that we are about to repeat some code 10 times. A loop is something we haven't touched on too much in our code yet, but it's super handy. If you want to repeat something, let the computer do all the hard work. You don't need to copy and paste your code or write it out 10 times. Let the computer do all that. So the code that we want to repeat 10 times is this function here, the tree function. So let's write tree. And we'll tell it it's going to start at X, Y, and Z plus 5. That just pushes it off to one side of the path. Okay, and that should be basically it. Now, if we were to run this, I'll show you what it does. It's not going to work properly. If we run this now, you get one tree. But we told the computer to repeat that code 10 times. So where are the other 10 trees? Well, they're actually built all on top of this one. So what we need to do is tell the computer each time we build a new tree that we need to move further down the path. So we've got to change the x-axis. It's going to be x equals x plus 6. That gives us a gap of 6 blocks between each tree. So I'm just going to walk down the end of my path here and watch what happens when I run this. I'm going to turn around so you can see it. So now what's going to happen is each time when I run my code, it's going to draw a tree, which is this one just here to start with, and then it's going to move down the path 6 spaces. So it's going to jump down a little bit further. And then it's going to loop back around and draw a second tree. It's going to jump down the path another 6 spaces and draw another tree. And that just keeps looping over and over again until it hits the number 10. So it's done it 10 times. Once it's done it 10 times, it just jumps out of that loop and stops drawing trees. So let's give that a run now. There we go. So we go for a quick flyby down our path here. You can see all the trees running down to the end of our path. And you can see our path is 56 blocks long and it pretty much finishes perfectly with my avenue of trees. In between each tree, remember, there is a space of 6 blocks. Okay, so that's a really quick way of drawing a stack of trees, just using a function and a loop. So that's one half of our avenue done. Let's do the other half. So what we're going to have to do here is, first of all, reset our x value back to 0 so that our first tree starts back down here. If we didn't do that, it would start way down the end of the path there and just disappear off into nowhere. We don't want that. We want the x value to start here. So we just set x to 0 again. And now we can put another comment and say grow 10 trees down the other side of the path. Alright, so it's pretty similar. We're just going to do a loop. So for I in range 10, because we want 10 trees again, we're going to run the tree function. So remember, it's going to run this code up here 10 times to draw 10 trees. And we need to tell it that it needs to start at the x coordinate, the y coordinate, and this time it's going to be z plus 5. Oh, sorry, not z plus 5, z minus 5. You might have noticed up here we use z plus 5, which pushed it over that side of the z axis. This time I'm going to do z minus 5, which will put it over this side of the z axis on the other side of the path. Once we've done that, we're just going to do x equals x plus 6 again to put a 6 block gap between each of the trees. And that looks pretty good to me, so let's give it a run. See what happens. Bit of a glitch there, but we've now got our avenue of trees. So we've got the path running down the middle, and we should have 20 trees in total, which run down 10 down each side of the path. Alright, so we are getting a little bit more complex now. A lot of that probably doesn't make a great deal of sense, but it's stuff we're going to be using time and time again as we go through the term. So you should start to pick up what's going on as time goes on. Don't stress if it doesn't make a lot of sense now. Just trust the process, and over time it will start making sense to you. So I will catch you in the next video.